So good evening everyone. So the reporters discusses all about error detection and correction in chapter 6 of data communication. So from the word itself, error. So usually by transmitting signal or transmitting data, the signals will suffers error. So it is a condition when the receiver's information does not match with the sender's information. So in during transmission, maybe the digital signal or the analog signal suffers noise that can introduce in errors. So that's why we are using error detecting codes. So whenever a message is transmitted, it may get scrambled by a noise. So we are already done discusses all about noise. So what is noise and what is the commonly source of a noise in a data transmission. So it may scrambled by a noise or the data may get corrupted. So to avoid those errors, so we are using detecting codes which are additional data added to a given digital message to help us detect if any error has occurred during transmission of the message. So the basic approach used for error detection is the use of redundancy bits. We are where additional bits are added to facilitate detection of errors. So there are some popular techniques for error detection. So we have simple parity check. So this is the first popular techniques, and also two-dimensional parity check, and the checksum, and the last is the CRC or the cyclic redundancy check. So first, the simple parity check. So blocks of data from the source are subjected to a check bit or parity bit generator form, where a parity of 1 is added to the block of its contents, odd number of ones, and 0 is added of its contents, even number of ones. So that is the simple parity check. So next is the two-dimensional parity check. So parity check bits are calculated for each row. So it is calculated each row, so which is equivalent to a simple parity check bit. So parity check bit is also calculated for all columns. So then both are sent along with the data. So at the receiving end, these are compared with parity bits calculated on the received data. So that is the two-dimensional parity check. So more likely they are this is the common rather than this simple parity check. So checksum. So in checksum, error detection scheme and data is divided into case segments, h of m bits. So in the senders and in the sender's end, the segments are added using one's complement arithmetic to get the sum. So the sum is complemented to get the checksum. So the checksum segment is sent along with the data segments. So and also at the receiver's end, all received segments rather are added using one's complement. So arithmetic to get the sum, say the sum is complemented. So if the result is 0, so the received data is accepted. Otherwise discarded. So that is the checksum. Next is the last the last techniques of error detection and correction, the CRC, or the cyclic redundancy check. So unlike checksum scheme, which is based on addition, CRC is based on binary division. So we are using division. So in CRC, a sequence of redundant bits is called cyclic redundancy check bits. So are appended to the end of data unit so that the resulting data unit becomes exactly divisible by a second. So predetermined binary number. So in cyclic redundancy check, at the same destination, the incoming data unit is divided by the same number. So if at this step there is no remainder, the data unit is assumed to be correct and is therefore accepted. So a remainder indicates that the data unit has been damaged in transit and therefore must be rejected. So that is the cyclic redundancy check. That is for the error detection and correction.